Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Let There Be Chaos by Rosie. And here are the rules. We have chaos construction rules where we need to divide the grid into regions of orthogonally connected cells and place the digits 1 through 9 once each in every row, column, and region. So what is an orthogonally connected region? It's a region where you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So as an example, this would be valid because to get from any cell in the region to any other cell in the region, you can just go through edges while staying within the region. This would be an example of one that is not valid, because even though these two cells can go to each other by going through cell edges while staying within the region, they can't get to the other cells in their region by just going through edges while staying within the region. They would have to go through a corner here or go through an edge while exiting the region, which is not allowed. So that is how orthogonally connected regions and chaos construction works. A digit in a circle indicates exactly how many circles contain that digit. A digit in a circle also indicates how many of the up to 9 surrounding cells, including itself, are in the same region as that circle. So for example, if we had a 6 here, we would have to have 6 sixes in total be in circles. So you would have 6 here, 6, you could have 6 here, 6 here, 6 here, 6 here, 6 here, and 6 here. And this would be valid because we would have 6 sixes in circles. So for a digit that is in a circle, that's how many circles contain that digit. Also, this would say that of the 3x3 box that they are in, this cell, the region that this circle occupies must have 6 cells, including itself, be part of the same region. So this would be a valid representation of this because we would have 1, 2, 3, 4, 5, 6 cells of the 3x3 area that is centered on the circle are part of the same region. And that's how circles work. We also have digits in cells separated by white dots are consecutive, and digits in cells separated by an X sum to 10. Not all dots and X's are necessarily given. So, for example, if this were, say, a 4 here, this would have to be 3 or 5 to be consecutive with it because these digits are separated by a dot. If this were, say, 3 here, this would have to be 7 because these two digits must add up to 10 because there's an X separating them. Excuse me. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, how many circles do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, sorry, 4, 6, 8, 12, 14, 17, 18, 21. And we have 4 distinct digits in circles. So it must be at least 4 digits. It could be more. And in fact, it doesn't have to be more. No, it does have to be more. Okay. In column 1, all of these digits, the digits that can be in the same region of it, this one can only have 4 total that are in the same region. This could have 6, this could have 6, and this could have 6. So if we tried to have these 4 digits be the only digits in circles, the problem with that is that you would have to have 3, 4, 5, 6 at most, but that only adds up to 18. So therefore, you must have at least 5 unique digits, because the 4 unique digits with these being 3, 4, 5, 6 is not enough. One thing you do know is that since we are missing a circle here, 9 cannot be in circles. And in fact, 8 is very unlikely to be 2, but... Yeah, actually, how would 8 work? 8 can't be in circles either, because 8 would have to be here, and then here. Well, yeah, you just can't have 8 in circles either. That's interesting. Because if you had an 8 in circles, the problem is 8 would have to be in a circle either in row 1 or row 9 or column 1 and column 9. And there's no way you can ever have an 8 in a circle to represent the number of cells in the 3x3 area surrounding it, because it's on an edge. You can only have at most 6 cells there. So that means the digits in circles can only be... Oh, that's even more interesting. You can't have 1 in a circle. Because if you had 1 in a circle, the problem is that we know all the cells, all the regions are orthogonally connected. And if you have a 1 in a circle, it's going to basically say, it's saying that none of the cells surrounding it can be of the same region. But obviously it has to orthogonally connect to the rest of its region, and so therefore it's not going to know. Like, so if we try to have 1 here, the problem is basically it's saying all of these cells are not part of the same region, but then this cell can't orthogonally connect to its own region. It would basically be just an invalid region there. So 1 cannot be in circles. So you can't have 1. That means you can't have 8 and 9 in circles. That means you have 2 through 7 in circles, and you have to add up to 21, right? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that means you have to subtract out enough digits to add up to 21. And one of them, you have to have 4 of them be from 2 through 6. That means, I think it has to be 2, 3, 4, 5, and 7. Right. It has to be 2, 3, 4, 5, and 7 to add up to 21. So that's 9 plus 4, which is 13. Wait. 14. 9 plus 5 is 14, plus 7. So that means these digits are 2, 3, 4, 5, and 7. Obviously, 7 cannot be any of these digits. This can't be 7 either. This can't be 5, because it's in the corner. So 7 has to appear in middle digits. It can't be on the edge. So this is guaranteed to be a 7 as the only digit in its column or row. This is guaranteed to be a 7 because it's the only possibility in column 2. So that means this cannot be 7 here. There's no 7 here. This has to be 7 for the only digit in column 3. That means this can't be 7, so that leaves this as 7 for the only digit in column 4. So no 7 there, which means this is 7 here as the only digit in column 5. That means this can't be 7. One of these two is 7, and one of those two is 7. These obviously cannot be part of the same region. So one region we're having here, so we'll make this green and this, and these are obviously part of different regions, and these must split. One must be part of this region and one must be part of this region. So we have, this is like a green-pink pair. Only one of these could be green. The rest of these has to be green here to satisfy that. And then the same thing here. This is pink. So this has two cells which are not part of its region. Therefore, this rest of this must be part of its entire region. How does that work? We have 1, 2, 3, 4, 5. I guess that could work. You could have, so these have to be part of the light pink or green regions here because we have 1, 2, 3, 4, 5, 6, 7 greens, 7 pinks here. This has 3, never mind. Okay, so this is not 7 there. So this has to be pink, light, or green here. In some order. We can have 2 here, so this can't be green here. We cannot go here for the light. Even if we tried to go here for the light, that doesn't work. Because if we go light, light, that would necessarily block these from having a region. So we cannot have light there. So green can reach here. Pink can't reach here because that's too many. It could be 1, 2. So therefore this can't be pink. It's light, which means this can't be pink. It must be light to be connected. Let's draw the boundaries around the entire grid. And then we have pink already done. Or sorry, not pink, light already done. Therefore, this cannot be light here. This is guaranteed to be pink. And we could have a pink here, or this can't be pink, because if that's pink, that would block the green from forming, from getting to this cell. And then this cell will not have a region. So this cannot be pink. So this is green here, and green and pink here. Which means this is definitely boundary. So this has 2 cells that are part of its region in the same region. So that's 2, which means this can't be 2. This has 1, 2, 3, 4, 5. So this must be 5. So this can't be 2 or 5 here. There's no 2 here, no 2 here. That's 3, 4, 5. We also have a 2 guarantee. Well, actually, we don't. Never mind. Okay. This has 7 cells, 7 cells. This has to be, cannot be 3 or 4, because we already have 5 cells that are part of the same region. So that's 5, which means this can't be 5. So this can't be green, because we have 1, 2, 3, 4, 5 already. So therefore, this is not green, that's pink. This can't be pink then, it's green. And it does not have 5, so it has to have 4 then. Cells part of its same region. So this is 4. So this is done as a boundary. This can't be 4 or 5. It's 2 or 3 here. Okay. One of these is a 7. This is 7 here. So if this were green, the problem is it wouldn't have 3 cells in the same region, or 4 cells in the surrounding region. So this cannot be green. Therefore, this is pink, which has 1, 2, 3 cells, part of the same region. So this is 3, and then this must be 4. So then we have a boundary here, and this has to be a different region than the green. Because this has 4 cells that are part of its same region, and if it were part of the same region here, that would end all the green cells. So therefore, that doesn't work. So this has to be part of some other region, which will make red. And that satisfies that. Green. Pink is done as a region then. So this is done as a region. And we have 5 cells in the same region as it. So this is 5. So no 5 there. Technically, this could be 4. Still. This has 7 cells that are part. So one of these is green. We're not sure which. This is 4. That eliminates 4 in the rest of the row. Okay, so we have 1, 2 in a circle, 1, 3 in a circle, 2 4s, and 3 5s. Okay, these digits are consecutive. It cannot be 2, 3, but it could be 1, 2. These digits are consecutive without 2, 5, or 7. That means no 1, 2, no 2, 3. It could be 3, 4, or it's 8 and 9 here. Because we don't have 5 or 7 available, that eliminates 4, 5, 5, 6, 6, 7, or 7, 8. So this is 3, 4, or 8, and 9. If this can't be 4 because of 4 in the column, so therefore this can't be 3 here. Okay. This cell is 7. Okay. We don't have any guarantee here, though. Okay. This can't be 7, because then we'd have to have a similar scenario as this, right? You'd have to have 6 digits here, which are part of this region, 6 digits here, which are part of that region, and these two must be part of these regions here, then. But the problem is, this 7, then, would have 3 cells, which are not part of its region, which is not allowed. So this cannot be 7 here, which means 7 in row 7 has to be here, which means this can't be 7. So that must be 7 there, excuse me. So this must be, we don't know. This 7 already has a digit that's not part of its region. So that means it's going to have one of these digits be part of its region at least. And if it has, so can it have both of these cells part of its region? If it tries, then this would be 7 this way. And I guess you could have 7 that way. So that could work. Um, This okay. Yeah, this could be 1, 2, no 2, 3, no 3, 4, no 4, 5, no 5, 6, no 6, 7, no 7, 8. It could also be 8 and 9 here. That's interesting. This adds up to 10. It can't be 4 because it's part of the region. So it can't be 4, 6, no 3, 7. This is also 1, 2, 8, or 9. No 2 here, so that means no 8 there. Hmm. Can this ever be 2 cells in the same region? Yeah, it could if red goes this way. And then this goes that way. Can this ever be 5? Yeah, it could be part of red here, and then red goes out that way, and then that way. That's possible. Three is also possible. Ooh, okay. Um, This is 2 or 3. That's interesting. So this will make medium. I guess we'll make this blue and we'll make this yellow. This orange. We also need some more 7s. I mean, this can't be red here because that would, it has to have 7 reds, 7 here and then try to connect, which doesn't work. Where is 7 in column 1? It has to be here. Which means, okay, so where's 1? Where's 7 in column 9? It has to be here. Because 7 was already in each of these rows. And red can't reach here, so this must be part of red. Okay, so if this is red, if this is part of red, it has to be 5. If it's not part of red, it's 2 or 3, so it can never be 4 here then. Hmm. Okay. How many 4s do we have in circles? We are guaranteed one of them here, and then one of them here, which are the 4s, right? Sorry, we are guaranteed because they have to have 4 4s. There has to be one here, and then there must be one here. Interesting. 5s. We have multiple possibilities for 5s. 3s. We have multiple possibilities for 3s also. Remaining digits in row 5, we have 1, 2, 3, 6, 8, 9. This can't be 3 because of 3 in the region. That's pretty much it. Okay, where can dark, yellow, and blue reach out to? So dark can go any of these, and then 2 more. Or this is not dark, this is medium. 2 more. Could go potentially 2 more there, 2 more here, 2 more here, 2 more here. It really can't go 2 more here. It could be 2 more there. 2. So none of these cells can reach that circle. Yellow has the same problem, right? So we have the 7 surrounding here, and we have 2 more trying to reach that. Same with the yellow. Same with the blue. So this has to be blue or yellow here, because that's blocked. So none of them can reach this cell, which means this has to be red, which means this must have 5 cells because it can't be 4. And it's surrounding it, it has already 4 here. So this is a 5, which eliminates 5 in the rest of the row. We have one more 5 in a circle available. Yellow can go to here. So medium can only go to here. So one of these is going to be red. One of them's not red, which is interesting. Red has to go here. So we have 5 here, which means we either have red here, or red here. That's 7. So we could go 2 more here, 2 more here. Medium can go up to here technically. Can't go here because that's part of another region. Blue could go here. Blue could technically go that way. And then blue could also go, technically go that way. 1, 2, 1, 2, 1, 2, 1, 2. This could technically be medium also. Technically. Technically, this could be medium also. Very unlikely. So we have 7 surrounding here, and then from there, you can go 2. So 1, 2, 1, 2, 1, 2. You cannot go in the 7. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So orange can go around here. This has to be dark. Orange can go to this way, to here, to here, to here. Cannot reach here. So technically orange can go all the way around here. Dark could go to any of these, really. That's gonna be interesting. It cannot go all the way down here because then that would be, it would have to go 3 this way to block this, and that's not allowed. So technically dark could reach to here. Could probably reach to here. Could reach here, technically. Technically could reach here. No, can't reach. Okay, cannot reach these parts. Because to do that, it would have to go through here, and then this would have not have 7 parts, 7 cells be part of its region. Okay. Okay. So orange is done. Medium is done. Blue is done. I didn't finish yellow. Yellow can go here, technically, can go there, could go up to here, but can't go there because, well, it technically could, right? You could go, yeah. Ugh, okay. Not great. Blue cannot go here because if it tried to go here, it would have to go through those. Well, technically, it could do that. Ugh. Okay. Dark cannot, though. You have to dark. It just doesn't work. Hmm. This can't be yellow. To do that, it would have 7 surrounding this cell. And then it would have to go. It can't go here. It could still go straight through. It would have to go 1, 2, 3. But that's 10 cells in the region. So this can't be yellow. This is definitely blue. So how many cells are surrounding here is the question. These cells here. That is 1, 2, 6, which is 8, plus another 6, 14, plus 8, which is 22. Only one of these cells can be non-blue, yellow, or medium. Right, 2, 4, we have 5 times 3, 15, plus 3 is 18, plus 2 is 20, plus 22. So only one of these cells can be non-blue, medium, or yellow out of these cells. Because we have 27, the 7s basically say that 21 of these cells are medium, yellow, and blue. So we only have one that can be non-blue, medium, or yellow. Which means any other non-blue, yellow, or medium cannot go into this region. So this cannot be dark. Let's do this again. Surrounding these cells, orange can go from here to here. Any of those are right, but not here. And the rest are fine. Red only goes once in. So this can't be orange here. Okay. Okay. So that means we have certain restrictions here. The question is how many digits are over here? We have 4 times 4 is 16. 17, 18, 19, 20. So that means 2 extra cells at least have to be filled by blue and medium here. Technically, this could be yellow here, right? Yeah. Technically, we could have yellows here. Okay. Hmm. What about this area? Okay. This is what, 11? Yeah, 11. Hmm. One of these has to be green here. So there's that. And then one has to be part of, at least one has to be part of the sevens, of the medium yellow and green regions. Huh. Is that right? That's 22, and then we have 23, 24. That doesn't feel right. I don't know why. Something feels a little off there if with the counting. 1, 2, 3, 4. We have, yeah, no. Pink is all done. Light is all done. Um, hmm. 12, 14, 22. The thing is, okay, so this is feeling a little weird. Um, because assuming that none of these digits are the extra regions, then that all 22 would have to be part of blue, yellow, and medium. But then we have these two, which must be part of blue and yellow. So that would be 20. Oh, 24. Right, right, right. It should be 20. Right. It should be 27. Right, right. Okay, so that makes sense. Never mind. I was adding up to 24 and thinking that that was three full regions, but three full regions is 27, which is 9 times 3. Okay. What does that mean? Ugh. Okay. This cannot be medium medium here because if this is medium medium, the problem is this cell wouldn't have a region because medium would have 7 cells around the circle, then 8 and 9, and this would not have a region. So this cannot be medium here. It's orange or dark. Hmm. So what we have here then is this is 11. So that means we have, including the 21, so this is 22 here. And then that's plus 2 is 24. Right. Two of these cells at least have to be part of some other, of one of these two, of light blue or possibly yellow. Wait, no. Yellow can't. Okay, so can yellow actually go to here and here? If yellow does, it has to go some roundabout way. And then to go roundabout way, it would have to be, so it would have 7 around here. it cannot just go straight to it, because then that would be too many cells that would not be part of this medium gray. So this can't be yellow here. And can it be yellow here? Yeah, possibly. That one, it possibly could. Right? Because then you have blue going all of these. Okay. Okay, we know this can't be orange because if we try to have well, okay. Yeah, this can't be orange. If this is orange, that would mean all the rest of these have to be orange because you can only get 2 here. The orange has to orthogonally connect, so then it would be that way, and then that would not work because then we'd have 3 cells not part of around the 7 circle. So this cannot be orange here. I think similarly we can't have orange here. Actually, I don't even know if we can have orange in either of these 2 spots. If we have orange here, that would mean there's 7 around here. And the problem is this wouldn't be able to form a full region. So neither of these can be orange. Therefore, they're definitely dark. Dark can only have 2 at most here, surrounding this 7. So it could be 1, 2, 3, 4, 5, 6, 7, 8. And then it has to go out. So this has to be dark also. Okay, so that's good. If this is orange or if it's dark, it has to be greater than 3. If it's dark, then these 4 already are dark cells. If it's orange, we have at least 7 oranges surrounding this, and therefore this would be, in that sense, 4 or 5, either way. So this has to be 4 or 5 guaranteed. So what does that mean? That means you cannot go dark, dark here. If you go dark, dark here, that would mean it cannot there cannot be any other digits around the 7 orange, the orange 7, except for orange. And then this would have to be a 6 area, which is not allowed in the circle. So this cannot be dark, therefore that's orange. Interesting. Technically, this could actually be red here, right? No, because we have 6 here, 7, 8, and 9. Right? That doesn't extend. Never mind. Could this be yellow? Actually, no, because then these would have to be medium. If this tried to go yellow, yellow. The rest of, actually, that's not even possible. Only one of these can be light. Oh, only one of these can be light. Sorry. Only one of these cannot be medium. That's that. I don't know how that turned out to be. Only one of these can be light. That's interesting. So only one of them can be light. Sorry. How did that come out again? That's weird. Only one of them can't be medium. So if this were green, these would have to be all medium. That would force all of these to be yellow. That would force all of these to be blue. So let's try that. If we have green here, obviously this can't be green. The rest of this is medium. The rest of this is yellow. The rest of this is blue. Um, that seems okay. You would have two cells here that are not orange or dark. Okay, what would that make these? That's kind of interesting. This would have to be 3. This would have to be 4. This would make that 2. Therefore, these would both have to be not yellow. So that would be both blue. And medium would have to go this way. Yellow would have to go here. This couldn't be 4 anymore. This would have to be 2. So it could not be medium. It could not be, obviously, yellow. It could not be blue. So this would have to be orange. And it'd have to be orange, orange going that way to connect. That's interesting. So no oranges here. No orange here. That would be medium. So orange, orange. Therefore, this couldn't be orange. This would be the full medium. This is looking like it works. So medium would be done here. We'd have one of these has to be yellow. So it's either yellow, yellow, or yellow, yellow. This is not yellow here. Not medium, so that would be red. So this is either green or red then, because if we tried it in this scenario when this is green, and that forced this to be red. So these can't be medium. So we'd have to have red, red, or yellow, yellow. And it cannot be yellow, yellow, because that would be then 4 here. So then this would have to be red, red, which means this is yellow, yellow. And then this would be 2. And we'd have a contradiction. So green cannot go that way then. Interesting. Yeah, maybe we should be using the numbers of where can 2 be. That's actually kind of interesting. But anyways, we tried that with green, so this cannot be green, which means this is green here. So that's done as a region. Red has to go to one of these. Can this ever be 4 then? If we have red, 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 obviously it can't be 4. It would be 3. If we try to go red, red, if we try to go through here, because this one of these two is not red, then it would have to go that way. Or I guess it could go that way, and then this could be 4 going that way. Okay, never mind then. This is actually kind of convoluted, though, for this portion. If we do red, 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 the rest of this would be medium. Can this ever be medium? No. If this were medium, it would block the red from forming complete region now. So this cannot be medium. Therefore, it's yellow or it's red. Okay, this can't be blue because if it's blue, both of these would have to be blue, and then this wouldn't have 7 surrounding it. This can't be. I mean, technically, it could be yellow. Technically, it could be blue. Okay, never mind. Yeah, this portion is actually kind of difficult. Figuring out the numbers in the circles was actually pretty easy, and that did give us a lot of information, but we kind of not that many. 1, 2, 3, 6, 8, 9 here. Remaining digits of column 1. We have 1, 6, 8, 9. Okay. Remaining digits of green are 1, 2, 3, 6, 8, 9. Okay. It's unlikely that these are 2, but it's still possible, right? Uh, hmm. Remaining digits of blue, or of pink, sorry, are 1, 2, 4, 6, 8, 9. No 4 here because of 4 in the column. Remaining digits of lights, we have 1, 3, 4, 6, 8, 9. No 4 here, no 3 there. Hmm. Uh, hmm. We are missing a 5 in column 3. And 5 cannot be part of light, pink, or green, or red. So, where is the 5? It can't be here because of 5 in the row, can't be in green, medium, or light, so it must be here, which means this cannot be red. So red has to go out this way. So this is red, which means this has to be red. So we have 1, 2, 3, 4, 5, 6, 7, 8. Cannot go red up here, so therefore this can't be red. And this can't be red, so this is the final red here. This then must be 3. That means where are the 4s in the circles? One of them has to be here, the other one is in column 8. So this is guaranteed to be 4. This is red here. So this is either medium or it's yellow. We're not sure which. 3 also eliminates, well, 3 eliminates 3 in the rest of the red region. So this is done as a region. And we have 1, 2, 6, 8, 9 here. Okay. So this is either part of yellow or it's part of medium. Interesting. This has red here. Therefore, yellow has to have at least 7 of, or has to have exactly 7 of these. So only one of these can be non-yellow. Same with this. This can only have 7. This has to have 7 exactly surrounding these. So only one of these can be non-medium. So since only one of these could be non-yellow and one of these can be non-medium, this must form a yellow-medium pair here. And therefore, all of this is yellow. And all the rest of that is medium. So this can't be blue. This has to be then all medium. This is medium. So we have 6 here. One of these is medium, so it's 7. This has to be yellow here too. So it's 6 here. One of these is yellow, one of these is medium. Okay. That means we have surrounding this blue cell, these two can't be blue. So therefore, these all must be blue here. So we have 7 blues here. This cannot be 5. So this has to be 2 or 3. It cannot be 2. So therefore, that makes this 3. So that makes that 3, which makes that 2. That's interesting. This can't be yellow then, because this must be 3 cells in the surrounding neighbors. We have all the 3s in circles, so this can't be 3. We have all the 2s in circles, so this can't be 2. So this is a 4-5 pair. This already has 5 cells in surrounding it, so this must be 5 here, and this must be 4. Well, that means none of these can be blue because we already have 5 blue cells surrounding it. So therefore, these can't be blue anyways, which means this can't be blue. Sorry, this has to be blue because that's the only place it can go to. Obviously, this can't be yellow anymore. So yellow, so this is medium, which means this can't be medium. That's yellow, and yellow has to continue out here. So we have 7 here surrounding this medium gray region. So this is done as regions here. This is 2. Cannot be 1 and 2 here. It's an 8-9 pair. That eliminates 2, 8, and 9 in the rest of the row. This is 4. This has to be 2. Obviously, it's not yellow. It cannot be medium because if this is medium, it would have 3 cells part of the same region. And why can't it be dark? It should be able to be dark. So it cannot be medium, so this is orange or dark. But dark actually seems pretty likely here. Cannot be medium, so therefore this can't be medium. Medium has to go out at least 1, 2 or 1, 2. And it has to go out here. So therefore this is medium. Therefore this must be medium too. So that can't be medium there. So this is done as a region. So we have 5, 6, 7, 8, 9. 1, 2, orange. So only one of these now can be dark because we have a medium here. So we have to have 7 more out of the 8. 7 out of these 8 total be part of orange. We technically could go around that way, but then this 4 wouldn't actually work. So if we try to go 4 around, okay, so say if this was orange, can we remove 2 out of these to have 4 oranges surrounding it? And the answer is no. So if we try to make this orange, only one of these can be removed as a dark because of the 7 that must surround the 7 oranges that must surround the 7, and so this can never be 4 then, if that's orange. So this cannot be orange, it's dark, which means the rest of these cannot be dark. So we have 1, 2, 3, 4, 5, 6. This can't be dark, it's orange. So we have 7 oranges there. This cannot be orange here then, because that would have more than 2 surrounding it when it's orange. So this must be dark, which means dark has to go all the way around here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. That leaves the rest of these as not dark. And these are the regions we have. And so now we just have to do normal irregular region Sudoku here to make this work. Okay. 3 eliminates 3 here. Remaining digits of the medium region are 1 through 6. So no 5 here, no 5 here, no 5 here, no 5 here, no 5 here. Where is the 5 in the medium region? It has to be here. Actually, we should just basically figure out where the 5s are. 5 in row 3 cannot be any of these digits because the 5's in the column, and these are filled out, so 5 has to be here. That gives us 8 5s. We know where the last 5 has to be. It has to be there. We've done all the 7s. 4. Oof. This can't be 4 because of 4 in the row. Remaining digits of column 7 are 1, 6, 8, 9. Okay. 3 eliminates 3. Oh, these can't be 3 because of 3 in the row and column. 3 has to be one of these 3. Remaining digits of yellow are 1, 2, 6, 8, 9. Okay. 4 here eliminates 4 in the rest of the row. So these can't be 4. Where is the 4 then? In the pink region, it must be one of these 2, which eliminates 4 in the rest of the column, so this can't be 4 there. Where's 4 in the light region? It has to be one of these 2. Remaining digits of... Okay, so we're guaranteed a 3 here in the dark region. So remaining digits in the dark region are 1, 6, 8, and 9. Because we don't have 3, because 3 is one of those. Blue... Okay, we have 5 and 7. That's fine. Okay. We have a 1, 2, 6, 8, 9 quintuplet in row 8, which eliminates 1, 2, 6, 8, 9 in the rest of the row. So that leaves the remaining digits as 3 and 4. So this is a 3, 4 pair. This can't be 4 because of 4 in the column, so that's 3, which makes that 4. That eliminates 3 from being here. Where's 3 in row 5? It has to be here. So we have 4 here, 3 here. Remaining digits of blue's region are 1, 2, 6, 8, 9 also. We are guaranteed 2 cannot be in the dark region here, so 2 has to be in column 9 in the blue region, which eliminates 2 in the rest of the region, so this can't be 2. That means where is the 2 in the orange? In column 8, it must be in the orange region, so we have 1, 2, 6, 8, and 9 here, and 2 has to be these 2, one of these 2. We are guaranteed 3 and 4 or in the orange region then have to be here, which eliminates 3 and 4 in the rest of the column. So no 3, 4 here, no 3, 4 here. Where is the 3 in the medium region then? It has to be here. So this is 3. Where's the 4 in the medium region? It has to be here. So that means this can't be 4 anymore. So this can't be 3 and 4 to be consecutive. It's an 8, 9 pair, which eliminates 8 and 9 in the rest of the box, or the region, I should say. We have a 1, 3, 6 triplet in the light region, so this can't be 1, 3, or 6. It's 4, which means this can't be 4. This can't be 3, obviously, because of 3 in the row. 8, 9 as a pair eliminates 8, 9 in the rest of the row, too. So this is 1, 6. We have a 1, 6, 1, 6 pair in column 8 and in the dark region. That eliminates 1, 6 in the rest of the dark region and the rest of the column. So this must be 2, 8, 9 here. We have an 8, 9 pair here, which eliminates 8, 9 in the rest of the column. So this becomes 1, 2, 6 triplet, which eliminates 1, 2, 6 in the rest of the region. So this can't be 1 or 6, it's 8 or 9. Okay. Huh. Okay. This isn't very easy irregular region Sudoku either. Let's see. Where is the 6 in column 1? It can only be one of these 3 cells, which eliminates 6 in the rest of the green region. 3 is one of these 2. That's pretty easy. Okay, where is 3 in column 3 then? It has to be here. So this is 3. That eliminates 3 here. Where's 3 in column 2? Can't be any of these cells because we have the 3 there now. So therefore this is 3 here, which means this cannot be 3. That also eliminates 3 from being here. Where's 3 in the orange region? It has to be here. So that's 3, which means where's 4 in the orange region? It must be there. That means this can no longer be 4 in the pink region. Where's the 4 in the pink region? It has to be here. Okay. That should give us all the 4s. I think it's all the 3s. Actually, 4, 5, 6, 7, 8, 9. Yeah, we have all the 3s also. Okay, so then this has to be 1, 6, 8, or 9. Cannot be 8 or 9 because of the 8, 9 pair in the row. So it's 1 or 6. Interesting. Okay, so let's start labeling these. We'll make this A here as a 1, 6, and that B. That means this has to be A over here, and B is one of these 2. This is A, which makes this B. A has to be one of these 2, but we don't know which. A has to be one of these 4, but we don't know which. This 1, 6 pair sees this 1, 6 here. This cell there, so therefore this cannot be 1 or 6. B is one of these 2, and we have an 8, 9 here. Therefore, that forces us not to be B or 8, 9. It has to be A, because one of these has to be an 8 and 9, because this can't be 8 or 9 anymore. Okay, so then this is A. Where is the 6 in row 8? It has to be one of these 3, which means the rest of the yellow region cannot have a 6. That's interesting. This is A. So we have A here, A here. Where's A in the medium region? It cannot be here, so it has to be. And we have a 1, 2, 6 triplet in column 6, which eliminates 1, 2, 6 in the rest of the column. This then has to be a 2, and this cannot be 2. It's 1 or 6, and it's A. So this is A here. We have A here, A here. Where A could be here or here, we don't know. Okay. B has to be one of these 2. Not too helpful. Ah. Where is... No, B's here. Never mind. Okay. B is here, so yeah, B and A both have to be here somewhere. So we have B here, B one of these 2, B one of these 2. B has to be one of these 3 here. Oh, but this is... Okay, this is 1, 6 as a pair, which eliminates 1 and 6 in the rest of the column. So no 1, 6 here, no 1, 6 here. Obviously, this can't be B anymore. This can't be 6 anymore, so one of these is a 6. Okay, which makes sense. So B has to be one of these 2. Oh, so B is one of these 2, which means this can't be B. So this has to be A here. So this is A. We have A here, A here. Okay, this can't be A. It's B, which means this can't be B. So this can't be 1 or 6. It's 8 or 9. We have an 8, 9 pair in row 2, which eliminates 8 and 9 in the rest of the row. So this can't be 8 or 9. It's 2. This can't be 2, 8, or 9. It must be 1, 6, and is A. That eliminates 1, 6 in the rest of the pink region. So this is 2, 8, and 9. That means this can't be 8 or 9 here. Therefore, this is B because it can't be A as a 1, 6. 2 eliminates 2 here. We have an 8, 9 pair in row 4, which eliminates 8 and 9 in the rest of the row. So no 8 and 9 here, no 8 and 9 here. Where's the 2? The 2 has to be here because of the 1, 6 pair. This is no longer, we remove 6s. This has to be A. This is 2. This can't be 2 anymore. So it's B as 1, 6 here. That 1, 6 pair eliminates 1 and 6 in the rest of the region and column. So this can't be 1. This can't be 9. So this is A and B. We have B and A here. This cannot be 1 because of 1s in the 1, 6 pair in the region. So one of these is a 2, which means this cannot be 2 because it sees both cells. Okay. Where are the A's? A is... We have everything but column 3. So that means this has to be A here. Because it can't be in the green region, can't be in the pink region, can't be here because of the A there, and it can't, that's B. So we have column 1, 2, 3, 4, 5, 6, 7. Wait, no, 1, 2, 3, 4, 5, 6, 7, 8. We know where the last 1, 6, A has to be. It has to be here. So this is A. We have 8, 9 pair here anyways. So that eliminates 8 and 9 here. So that's 2, which means this can't be 2. It's 1 and 9. So A has to be a 6. And B has to be a 1. So it cannot be here. So then this is 1. That means no 1 or 6 here. We have, this can't be 1 or 6, it's 2. No 2 here. This can't be 1 or 9 or 6, so that's 8. That leaves this as a 2 there. No 2 here. Where's the 2 in the yellow region? It must be here. That eliminates 2 here and 2 here. Where's 2 in the pink region? It must be there. Again, this 8 eliminates 8 here, so it's 9, which makes this 8. 8 eliminates 8 here, so it's 9 and 8. 8 eliminates 8 here, so it's 9 and 8. 9 eliminates 9 here, so it's 8 and 9. 8 eliminates 8 here, so it's 9 and 8. 8 eliminates 8 here, so it's 9 and 8. This must be 1. 8 eliminates 8 here, so it's 9 and 8, which makes this 9, and that 8. Yeah, the irregular region Sudoku was actually quite challenging. Well, it wasn't even a regular region Sudoku. It was basically figuring out what these regions could be was actually quite challenging in itself. I will say that I'm not the best. I don't do that well in the geometric part of the chaos constructions. It sometimes takes me a while to basically go through all the different possibilities. And sometimes I don't see things correctly. So, but, you know, I enjoyed it. I always enjoy chaos constructions, even if I'm not the best at it. So yeah, this was fun. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.